Okay, so we are on to our last topic for AP Unit 6, integration. We are going to talk about improper integrals. So really, as far as integration methods goes, we're good with those. You've got your basic integration and some memorization stuff that ties into trig. You've got integration by parts and U sub, and then partial fractions. So what we are going to do is we're going to tie in what we know about those integration methods along with some interesting boundaries. So you've dealt with definite boundaries before, and plugging those in simple. Here's where it gets interesting. We're going to be dealing with infinities and negative infinities, and also just numbers that defy the boundaries. And so a couple of terms that you're going to hear are diverge and converge. And this will actually come back around at the end of this course when we get to series. So it is important to understand these words. So when we say that something diverges, it means that we're not going to get an answer, basically. So it's going to go to infinity or go to negative infinity, okay? There's not a chance that it's ever going to give me an actual number. Now, if it converges, that means that when I integrate, I actually, eventually get to something. I might get close to 0 or 1 or a fraction or anything, okay? So diverge, the limit is going to be approaching infinity, and converge, the limit's going to be approaching a number. And so because we have an infinity or an issue in our boundary, we do have to look at the limit. We can't actually plug in an infinity. So this is going to be a lot easier if you have a good grasp on how to take a limit, which also ties into L'Hopital. So you'll hear me kind of talk about some of those things. If you are a little rusty on those, you can always pull them up on Khan or AP Classroom. So the first thing that I like to do with this problem is I want to rewrite it as the limit as x approaches, or not x, b approaches infinity. So your a is 0, your b is infinity. The infinity is the problem, okay? We can't actually plug that in, but we can look at the limit as it approaches infinity. This is just proper notation. If you are taking the AP test, this is the way they want to see it written, from 0 to b. If you're not doing the AP test, or you're just doing a test for me, or you're doing some homework, you can kind of be a little bit sloppy about this. I'm going to show you the correct notation on this problem, and then I might get a little sloppier later, just for time's sake. So the first thing I need to do is really just integrate this problem. And to me, what's going to be helpful is, let's think about all of those methods that we know. Sometimes like making a little checklist off to the side, or as you're practicing these, kind of going through, does this remind me of anything? And really this is some U sub, and this is an easy U sub problem. And you really don't even need to set up the U. You're kind of thinking like just reverse chain rule. If I were taking the derivative of e to the negative x, it would just be e to the negative x with a negative out front. Well, the integral is going to be the same, because that negative, when you flip it, it's just the same. So let's go ahead and write that out. So e to the negative x negative. And all along, you really should be writing as b goes to infinity, and I'm going from 0 to b. I now need to plug in that b. I would never plug in when there's a negative exponent, so I would like to rewrite this. I have seen some confusion when you plug in and there's a negative exponent, and it's so easy just to rewrite that. And let's just put in our b. The limit as b goes to infinity. And then I'm subtracting this negative 1 over e to the 0. So I can just go ahead and plug in 0. But with the infinity, I have to think about the limit. So, what is this as b approaches infinity? So b is infinity. It's really, really big. So if we take e to something that's really, really big, it's going to be really, really big. So I've got something small like 1, negative 1, over something really big. And if you recall from AB, when you have something small over something really big, that limit is going to approach 0. Okay, if we have something big over something small, then it's just going to diverge. So this actually converges to 0. The two negatives are going to become a positive. And we have 1 over e to the 0, which anything to the 0 power is 1. And that all simplifies to 1. That's it. Gotta love calculus when you do all of that work and the answer is 1. That's just the way it is. Okay, so I do have some more of these. If you would like to try it at any point, feel free to pause it, especially just to practice your integration at this point, because we have done a lot of practice with that. And then if you just want to work through the improper integral part with me, you can do that. So this is another easy one to integrate. 1 over x is just ln of x. So we're going to look at the limit as b approaches infinity for ln of x. 1 to b. I kind of skipped a step there, but this is fine. You can skip right to this point. So let's go ahead and plug in our b. So this is nice because ln of 1 is 0, if you recall what the graph of ln looks like. So ln of 1 is 0, so that's just going to go away. But what is the ln of infinity? So ln of b as b approaches infinity. So if you go look on the graph, as we go to the right, our graph, it's slow, it's gradual, but the graph of, it's a horrible graph, but it's increasing, okay? So ln of infinity is just infinity. This means that my answer is diverge. If I take infinity and I subtract 0, I still have infinity. Honestly, if you simplify any part of an integral in this and you're getting something that diverges, the whole thing diverges. If I have infinity and then plus 5, it's still infinity. If I have infinity minus 1,000, it's still infinity. So if you have any one part of your answer that's infinity, there's really no point even finishing the rest of the problem because it's not going to make a difference. All right, here is another one. This should look very familiar. 1 over 1 plus x squared, that is arctan. Now, all of these so far have been b approaching infinity. This could just as easily be, a is approaching negative infinity. You do tend to see more of these types of problems, but the other one could happen, and it's the same concept. So with this trig function, we have to think back to the unit circle. So arctangent, that is going to be what angle gives me out that value, so 0. So arctan of 0 on the unit circle probably going to be one of these points. So if we do y divided by x, I get 0 at 0 or pi. I'm just going to use the first one that I got at this point. And for the limit as b approaches infinity, so we have to think what angle could give us out an infinity. In order to get infinity, we would have to have an indeterminate form. Our best chance of getting out an infinity would be having something big over something really small. And when you're thinking about the unit circle, and you have all your other coordinate points here, you have pi over 4. When we divide those, we get out a 1. You've got your radical 3 over 2. So we really need that indeterminate form, and that's going to be 1 over 0. And that would be pi over 2. So my answer for this one would just be pi over 2. So you can just think about that using the unit circle, or some people just have it memorized. Like a lot of people will just memorize that ln of infinity is infinity, and that arctan of infinity is pi over 2. So it's up to you. You don't have to memorize it, but if you want to, go for it. Okay, I have another example that's a little bit more advanced. And then I'm going to show you one where there is an issue, but there's not an infinity involved. So think about that for a sec. Okay, so with this problem, I just need to integrate it. I'm going to be kind of sloppy on this one with the way I work it out, just to kind of show you that, you know, if you are doing a multiple choice question, or you're not taking the AP test, like, you can solve these a little quicker just by being, a little bit sloppier about your notation, and I don't have a problem with it. So I'm going to integrate this just the way I normally would. This would be a great u-sub problem, because if I take the derivative of ln of x, I'm going to get 1 over x dx. And I like that because whenever I divide by this, that x on the numerator is going to cancel with this x on the denominator. And I can replace that dx with a du. So I'm really just integrating 1 over u squared du. I'm going to bump that to the numerator and make it negative. A little bit of basic integration. Just add 1 and divide du. Almost wrote dx. And actually, let me just go back here because I don't need that symbol anymore. Just get in such a habit of writing it. And let's go ahead and plug back in that to the -1, and that should be in parentheses. And really the best thing to do is just to put that back in the denominator. Probably could have gone to straight from here to here. So now I'm going to plug in infinity and 1. So I've got okay. So I've got ln of infinity, which is infinity. And when I do 1 over infinity, that's approaching 0. So this whole thing is a 0. I've got these two negatives, so that's going to make a positive. ln of 1 is 0. But 1 over 0 is infinity if we're thinking about a limit. It's an indeterminate form. So the whole thing just diverges. There's not an answer. So gotta love that, doing all that work, and it diverges anyway. I do want to show you just a couple other problems. We've done the same kind of thing over and over again, but just to show you, like, this can tie back into any type of integration problem that you've done. So, when you look at this, hopefully, you're thinking, okay, that's basic integration. I need to split that up. And then now integrate both of those. Then you can plug in your infinities and your 1s. When you see this, hopefully you're thinking partial fractions. I need to factor. Same thing. So improper integrals is not just U substitution. It's not just basic. It can be applied to partial fractions, integration by parts, any of those methods. But the idea is the same. If your upper boundary is infinity, then we want to make B approach infinity. If your lower boundary is negative infinity, then we want to make A approach negative infinity. And it is possible to have a problem that goes from negative infinity to infinity, so you have to look at both of those as limits. I do want to show you one last problem, because this is technically an improper integral problem, even though there is not an infinity involved. And the reason it's improper is because one of the boundaries is what I like to call an issue. There's an error in the domain. So if one of the boundaries is a problem, or something in between one of the boundaries is a problem, we do need to look at the limit, okay? So even if there was something, let me just tweak this problem slightly. And I'm not going to work it out, but I'm just going to throw this out there. Let's say I was doing this problem, and my boundaries go from 0 to 2. Well, 0 and 2 aren't a problem, because that's not going to cause me to divide by 0. And that's what you really have to watch out for, like all those things that you would have learned in algebra. I'm not allowed to divide by 0. I'm not allowed to take the square root of negative. So anything that defies those domain rules. So if 1 is in between 0 and 2, and 1 is something that makes this 0, then I'm going to have to split that up into two problems. I'm going to have to go from 0 to 1, and then 1 to 2, and I'm looking at where B is approaching 1 and where A is approaching 1. Okay, and you just would have two problems. So it's rare that you see that, but it could happen. Okay, so let's work through this one. 2 is an issue because when I divide with 2, that's going to give me 0. So I have to replace 2 with a B. And we are going to look at limit as B approaches 2. easy integration problem. Just ln 0 to b. Okay, so we've got right over here, b minus 2. If we plug in 0, that would just be negative 2. And we could simplify that to just 2 since we're taking the absolute value. Okay, so now we have to think about ln of 0. Now we don't actually know what ln of 0 is. If you think about the graph of ln, as we approach 0, think about the limit. As you approach 0, where is this graph going? It's going to negative infinity. So that right there is going to be a diverge. If you were unsure about the second part of the problem, it honestly doesn't even really matter, because if any part of the integral is going to diverge, then that's going to cause the whole thing to diverge. All right, that's the idea for improper integrals. Just watch out for something in the boundaries that breaks the laws of domains, and watch out for those infinities. And you really want to think about a limit, because we don't actually know what the value of ln of 0 is, but we can talk about the limit. And sometimes drawing a graph is really helpful, especially if you're more visual like me.